This is a quick video going over the notes from section 3.3 for those of you that were absent. The first thing that we talked about is that essentially you'll see some resources that say, that talk about an S, and S is the same as theta. The reason why is because when we talk about our unit circle and we talk about circle with a radius of 1, if we talk about this arc length, and recall the other day we said that S was equal to r theta, if the radius is equal to 1, then S equaling r theta will be r of 1 times theta, and therefore we just get that S is equal to theta. Really all that you need to know about this is when you see S used, it is the same as theta. That's about it. All right. Okay, so we want to begin by looking at the different ratios, and we know that sine is y over r and cosine is x over r, and both of these have an r in the denominator. Since we have an r in the denominator, it is impossible for these functions to ever be undefined. So no, they can never be undefined because r can never equal 0. So for that reason, there's no angle that wouldn't work for sine and cosine. So we can say that all angles exist for the domain. So we can say from negative infinity to infinity. Next, we can talk about tangent and secant. And tangent will be y over x, and secant is r over x. And since x can equal 0, then these functions can be undefined. And this will happen whenever x equals 0. So we talked about, well, where would this occur? Now, if we were to look at our circle and we were to find all of the points where the x value is 0, that would happen here and here. So first, that occurs at 90 degrees and 270, which if we think about these in radians, would be pi halves and 3 pi halves. Now, if we went around the circle again, so this would be the first time, the second time if we went on again, that next time would be 5 pi halves, and then if we kept on going, we would get 7 pi halves. So when we look at these numbers, these are odd multiples of pi halves. So the way that we could write our domain is we could say that the function is defined for all angles, I don't know what just happened there. Hold on a minute. Okay, sorry about that. So this is defined for all angles theta, such that theta is not equal to, and then we want to say odd multiples of pi halves. So the way that we can write an odd number is 2n plus 1, and that represents any odd number because 2n represents an even number, and if you add 1 to an even, you get an odd. So that's how we can represent all of the angles where the tangent or secant function would be undefined. If we went through a similar process for cotangent and cosecant, we would have x over y and r over y. So similarly, these functions would be undefined when y equals 0. All right, so when does that happen? If we think about the points where y equals 0, that occurs at 0 and 180. So if we go around the circle, undefined, undefined, we can keep on going around. And every time we reach an angle that is coterminal with 0 or 180, we will be undefined. Now we want to think about those angles in radians, so that would be 0 and pi would be your 0 and 180. And then if we go around again, that's 2 pi, and then another 180 is 3 pi, and so on. So in this case, instead of being odd multiples, we actually see consecutive multiples of pi. So we can say that this function is undefined, or it is defined for all angles theta such that theta is not equal to n times pi. And in these cases, n is an integer. All right. So the last skill that we worked on was taking these angles that are way bigger than 2 pi or smaller than 2 pi and evaluating them based on unit circle. So essentially what we want to do is we first want to find an angle between 0 and 2 pi. And so the way that we are going to do that is we are going to add or subtract 2 pi as needed. So if we look at this first problem, the angle is too big. So I'm going to subtract 2 pi. Now when I subtract 2 pi, I want to subtract it with a denominator equal to the denominator of my problem. So I would do 12 pi over 6, which is equivalent to 2 pi, just like denominators. So now my problem becomes the cotangent of 11 pi over 6. And since I'm within the 0 to 2 pi, I know that I'm good. Now that I've gotten that, I want to go ahead and I want to find the quadrant, and I want to find my reference angle. All right, so this angle right here, this is almost equal to 2 pi. This is a 4th quadrant angle, and I want to find my reference angle. So my reference angle, since I have a 6 denominator, is going to be pi 6, which is the same as 30 degrees. So at this point, you're trying to find the cotangent of 30 degrees, which we know to be root 3, in quadrant 4, which makes it negative. So our answer will be negative root 3. All right, pause the video and go through the same steps for the next question here. All right, so here this angle is too small, so we need to add 2 pi. Again, denominator of 6, adding 2 pi, we would add 12 pi over 6, which is going to give me the problem secant of 5 pi over 6. I have gotten to be between 0 and 2 pi, so I'm good. Now I'm going to go ahead and find my quadrant. Since my numerator is less than my denominator, I know that I'm in the top half of the circle, specifically in quadrant 2. Now I want my reference angle. So my reference angle, again, I have that 6 denominator, so my reference angle is pi 6, or 30 degrees. So I'm looking for a 30-degree secant. Secant of 30 degrees is basically the reciprocal of root 3 over 2. So we're going to have 2 root 3 over 3, and in quadrant 2, that answer would be negative. All right, I'm going to give you 2 more to try on your own. So I want you to do the sine of, we'll go with 5 pi thirds, and I want you to do the tangent of negative 11 pi fourths. Pause the video and try those 2. Okay, if we look at our first example, this angle here, 5 pi thirds, is within 0 to 2 pi, so we don't need to adjust the angle. We can recognize that that's in quadrant 4. And in quadrant 4, this reference angle of pi thirds, or 60, would have a negative answer, so it would be negative root 3 over 2. If we look at tangent of negative 11 pi fourths, this angle is really negative. So we need to add 2 pi, and then we need to add another 2 pi. Now notice that this next time, when I add 2 pi again, I still have to add a whole 8 fourths. Even though 4 fourths would be enough to make it positive, we cannot do that. We have to add in increments of 2 pi. So I end up adding 16 pi fourths, which gives me tangent of 5 pi fourths. From here, I can see this is quadrant 3, reference angle of pi fourths, or 45 degrees, and therefore it is positive 1. All right, the last skill that we did was the idea of working backwards, and this was very similar to what we did when we were working in degrees. The only difference is that now we want to generate our answer in radians. So if we look at example 2, part A, we have cosine of s equals root 3 over 2. So the similar steps that we did before, we first want to find which quadrants we're going to be in, then we're going to find that reference angle, and then we are going to get the answers. Those are the steps that we want to take here. All right, so if I look at this problem, cosine is positive. That's going to happen in quadrants 1 and 4. So we've got quadrant 1 and 4. Reference angle, cosine is root 3 over 2 at a reference angle of pi 6, which is the same as our old 30 degrees. And then now I need to find my answers. So my quadrant 1 answer is simply pi 6. And my quadrant 4 answer, remember the rule, we double the denominator and subtract by 1, is 11 pi over 6. All right, go ahead and pause the video and try part B on your own. Okay, for part B, our cosecant is going to be negative when y is negative, and that happens in quadrants 3 and 4. Reference angle, recall we're thinking of, well, when does my sine equal 1/2? And that occurs at the pi 6 reference angle. So I need to do a pi 6 reference angle in quadrant 3 and 4. For quadrant 3, my angle, the numerator will be 1 more than the denominator. And then for quadrant 4, my numerator is 1 less than double the denominator. All right, in our final problem set that we did the exact same skill but using the calculator. So now the main difference is that we still need to think of our quadrants. So for sine is going to be positive in quadrants 1 and 2. Oops, 1 and 2. And then from here we want to go ahead and we want to use our calculator. So we will do sine inverse of 0.5478, and that gives us our starting angle. And after doing that, we are going to get the value 0.5797. And remember, you need to have your calculator in radians, otherwise you will not get the correct answer. Now this is like our reference angle. So we want to put this angle in quadrant 1 and in quadrant 2. So if you visualize this, we've got our angle here and here. So this angle is already going to give me my quadrant 1 angle. To get my quadrant 2 angle, since this angle is above the x-axis, I know that it's going to be less than the 180, or in radians, less than the pi. So I have to do pi minus that 0.5797 answer. And we will get our final answer of 2.562. All right. Now when we do part B, this is a cotangent. Recall, if you don't have an 89, you have to do kind of like a double flip when you put this in the calculator. So you'd want to enter this as tan inverse of 1 over 0.3364. And when we type this in, we end up getting 1.246. Now, cotangent is going to be positive in quadrants 1 and 3. And this decimal right here is my quadrant 1 answer. So to get my other answer down here in quadrant 3, just like before, I think about where is it located in relation